We want to now look at the idea of how to start describing the functions that we have. And the first way we want to look at the description here and talk about it is that how do we look at the values of the x values we can take and the y values we get when we do that. So what we want to introduce a couple of new terms. Now the first one's domain. So when we talk about the domain of a function, we're looking at the x coordinates of the ordered pairs. So if you're asked to find the domain of the function, you're looking at the x values. If you're talking about the range, then we're looking at the y values. So really domain can be determined by what the function is, but then the range can be determined what values we can put in for the domain, or it might be other restrictions. Now most of the time it's going to be all real x or all real y values, and we're saying real values because we're talking about them being in the real number system. So a lot of times it could be any x value or any y value. But there are situations sometimes when we have restrictions, and that's where we're going to look at the examples here. So the first one here is like, for this function here, square root of 9 minus x squared. Well, if that's the case, we know we can't take the square root of a negative number, which means anything we're going to have under the square root sign has to be greater than or equal to 0. So what values would we have here that would be greater than or equal to 0? Well, that means x has to be greater than minus 3, or x has to be less than or equal to 3, because any values that are less than minus 3 or greater than 3 will give us an error. It will give us a situation where we get that being less than 0, because x squared basically has to be less than 9 every time. So that has to be a number that's less than 3 or greater than minus 3, or between those. And if that's the case, then that will actually give us a value. But any other values there won't give us a value. Now when we look at that, we've got the square root of 9 minus x squared. So really, if x is equal to 3, then we're going to get 9 minus 9, and that's going to give us 0. So all the other number that's critical here is if x is equal to 0, because 9 minus 0 would give us not a square root of 9, which is 3, which means that really all the y values we're getting out, we're going to take the square root of something that's less than 9. So the largest number we're going to take the square root is 9, which that means that's the largest y value we're going to get is 3, and the smallest one we're going to get is 0. So it's somewhere between 0 and 3. And that's where, just by inspection, we're looking at that going, well, the square root of 9 minus x squared depends on the x values we get, and then the y values will follow from that. So if we're looking at 1 over x minus 2, well, again, we're looking at the restrictions. Now, really, we could take any x value here as long as we don't get a division by 0 error, which means that x minus 2 can't equal 0. So that means if that's the case, well, x can't equal 2. If x is equal to 2, then we won't be able to get any answer there because it will be dividing by 0, so that'll be a problem. The other one for the range though, really we could get any number out. The only situation we won't get is where y is equal to 0, because you can't have 1 dividing by a number and get an answer of 0, because you have to have 0 dividing by something to give you 0s, and it's always 1 up top. So there's the other restriction. First one we have was taking the square root of it, and we get restrictions, and 1 over a function is going to give us a problem as well, because we can't divide by 0. So that's really the only major issues you're going to have for the domain. If you're looking at something like this, x squared plus 3, well, really it doesn't matter what value you put in for x. You can square any number. So there's no restrictions, and that's why we say all real x, because any real number for putting in for x won't be a problem. For the range though, if you have a look there, because that's x squared. Now if we have a look at x squared, when we put all the numbers in, they're going to be positive. So the smallest value x squared would be 0. X squared, no matter what we put in, will be at smallest 0, which means for y there, if that's the smallest value that we get there is 0, we'll have 0 plus 3, which means that y is never going to be less than 3, which means y could be greater than or equal to 3. It's going to be giving us those values. So it can never be less than 3, so that's our range, is y greater than or equal to 3, because x squared is never going to be less than 0. So this time, square root of x squared plus 2. Well, again, we'll have a look here. We don't have any problems, because putting in any value for x there is going to square it, and then we're going to add 2, which is always greater than 0. So that's not a problem, because we'll get all real values of x. being legitimate there. No, we can't. There'll be no problems. But there'll be no number we could substitute in there, and we'll get the square root of a negative number. But again, what are we going to see for our range? Well, as it's saying here in this little bubble here, x squared plus 2 is the smallest value of that is 2, because x is equal to 0 would be the smallest value we can put in there to give us the smallest value of 0. So it's always going to be 2, and then we take the square root of it, so y is going to be greater than or equal to 2. So again, some more examples of different functions we're going to see, and any restrictions we have. 1 over 3 minus x, well again, we get 3 minus x can't be equal to 0 because we can't divide by 0, so x can't be equal to 3. That's the only restriction. Otherwise, all real values are working for us. And then, because of that as well, there's no way we could get y being 0, because we can't have 0 divided by something to give us the 0. So it's never going to be equal to 0. Otherwise, all y values are legitimate. This one here, y equals 2x plus 5, not a problem putting any x value in, and we'll get any y value out there. So there's no restrictions, because we can put in different types of numbers for x, and we'll get different values of y. So all real values are legitimate there. And here's one where we've started to put all our restrictions together. So 1 over the square root of 4 minus x. So again, we can't have a division by 0 error, but we also can't have a negative under the square root. So really what we want is 4 minus x to be greater than 0. So as long as 4 minus x is greater than 0, which means that if that's the case, x has to be less than 4. If x is greater than 4, that would give us a negative. Notice it's only greater than here and less than here, not equal to, because if we could take the square root of 0, that's not a problem. So it's not a problem putting the 0 there, but then we'll get a division by 0 error, which would be a problem. So we've got to take both situations into consideration. And seeing that we're going to get only positive values out, we're going to get y being greater than 0. We're not going to get 1 over a negative answer, and we're not going to get a 0 answer again, because there's not 0 divided by anything. So y is always going to be greater than 0. So there's our restriction that happens for our y values because of what's happening in our x values. The x values are a bit easier because we can look at our functions and go, okay, we can imply restrictions, but then we've got to consider what it does to our y values and be able to react accordingly and do our range. So there's two terms, domain and range. So we've got to make sure that we can look at graphs and be able to define our graphs to be, and look at their domain and range and be able to talk about that, because if we don't get our domain and range right, it makes our drawing of graphs later on a little bit harder. So we've got to be able to get our correct domains and ranges as we go along.